I gotta say, it's totally awesome to be here today. I feel like a kid in a candy shop, and especially felt that way in the earlier session, hearing from my water monitoring brother and sisters from another country. So that was a lot of fun, but super stoked to be here. I'm Julie Vastine, and I direct the Alliance for Aquatic Resource Monitoring, also known as ALLARM. That is an acronym that our agency friends in the States don't necessarily appreciate so much. And yes, I've heard every alarm joke that you could come up with. And Rod mentioned this a little bit, but we are a nonprofit that is housed out of an academic institution, and we're 50% supported by Dickinson College, which is a small liberal arts college in the state of Pennsylvania. All right, so a little bit of a quick background on who ALLARM is. We were founded in 1986, so we are a 28-year-old citizen science-based organization, and our central mission as an organization is to empower communities with scientific tools to monitor, protect, and restore primarily Pennsylvania waterways. And so our mission is all about putting those scientific tools into the hands of the communities that want to protect their resources. And I should mention there's 3 full-time staff, and we also employ Dickinson College students, and then we also have a faculty science advisor as well. Oh, that's going backwards. Here we go. All right, so for those of you, Pennsylvania, that's where we are. There you go. A little bit of our history in a quick nutshell. We have been flirting and talking about these citizen science models, and ALLARM has had experience with all 3, though our founder and our science advisor might not appreciate me calling our acid rain program contributory. It really is. So we have had experience with all 3 models, and so I'm not going to be talking that much about our acid rain program. I'm going to be primarily focusing on our Watershed technical assistance program, and then our shale gas, aka fracking, technical assistance program with this presentation. So this map here is our 28-year history in a nutshell. So we got our start looking at the impacts of acid rain on Pennsylvania waterways. Because of the number of coal-fired power plants to the west of us, Pennsylvania has the most acidic rainfall in the United States. And so a legislator, one of our state legislators, brought together a team of scientists saying, hey, what exactly is the impact of acid rain on Pennsylvania waterways? Which our founder was in the room in that conversation, which led to our first citizen science effort, which lasted 17 years. And the blue dots on this map here represent over 500 sites where volunteers monitored streams for pH and alkalinity data on a weekly basis for a minimum of a year. We had a number of volunteers that did more than 10 years. So that's that program. And I'm not going to talk about it any further than that. The green on the map represents our Watershed based technical assistance program. And that's that co-created model. So with this program, the community identifies an issue or concern in their watershed, and then we help them to design and implement their program. I'll talk about that a little bit more. And the yellow represent the counties in which ALLARM has done training for communities looking to do monitoring around shale gas extraction or fracking in the region. And you'll notice that takes us into the state north of us, New York, and southwest of us, which is West Virginia. All right, so US-based, aquatic-based citizen science. We heard from Elaine earlier of one program in the States. But in the States, aquatic-based citizen science is commonly referred to as volunteer monitoring, or VolMon for short, if you want to be on the in on that. And we've had programs dating back to the 1970s. According to a survey that was done by Christine Stepanek out of University of Wisconsin, who characterized 380 water quality monitoring programs throughout the country. There are 48 out of the 50 states have active programs. But today I'm going to specifically focus on Pennsylvania. That's where I'm from, and those are the programs I know the best. Something to know about the state of Pennsylvania. This is your trivia that you can leave with. We have over 85,000, sorry, I didn't convert this to metric, miles of streams and rivers. We have more streams and rivers per land area than any other state in the United States, which makes us extremely water rich. We have a long history as a result of being such a water-rich state of having communities engaged in water protection efforts. And something that I wanted to talk about today throughout this presentation is highlighting how you connect those citizen efforts to policy efforts. And I gotta say that with the change of government and governors in a 4-year cycle, that has definitely come into play within the Pennsylvania volunteer monitoring movement, because we're often at the, we're often at the mercy of our state agencies that take the direction from our state governors, and that's a little bit messy. But all in short, so in '86, ALLARM formed. In '96, our state environmental agency created a citizen volunteer monitoring program. And this is at a time when the governor and the secretary of the agency was like, woo, volunteer data, that's really awesome, let's support it. That was nice. They followed that up, and in the period of '96 to 2000, it was documented there were 125 groups doing water monitoring. In 2000, from 2000 to 2006, over $1.2 billion of grant money went into water protection efforts. And so that led to this huge increase of watershed activity. We went from 125 groups to over 580 citizen groups engaged in watershed efforts, which is really cool. In response to that, all these communities started collecting data. And they started collecting data without having access to good quality assurance, quality control measures, access to good technical assistance. And so in the midst of this, in 2001, a network of service providers like ALLARM formed together to create a consortium to provide free technical assistance to those 580 community groups doing stream monitoring. In 2006 through 2009, we saw an ebb and flow in our movement. We lost a number of groups. A lot of people answered the questions that they wanted to address. They started to burn out with their long-term monitoring. We also went through a period throughout the United States, worldwide, but in the state of Pennsylvania too, of an economic downturn. So we saw a little ebb and flow in that period. And then in 2010 is when fracking monitoring really took off, and that reinvigorated a number of communities. And today we have a lot more communities re-engaged in water quality monitoring throughout the state. All right, so data to policy action. So one thing that we have working for us is in the United States we have a federal act, the Clean Water Act, and that act requires that the state agencies develop stream standards, and it also requires that the state monitor waterways every 5 years. Okay, so if you're a state with over 83,000 stream miles and your state agency only has 167 permanent monitoring sites, you might need some extra help, So that's a great opportunity for aquatic citizen-based monitoring. And there's definitely a lot of considerations when you think about what data can volunteers collect. And there's a lot of quality volunteer field kits out there. Not all field kits are created equal. You have to test them. But there are a lot of good quality field test kits that volunteers can use to collect data and be used in addition to cooperating that with certified lab analysis. So here's the tips for data use I'm going to put out up front. This is our mantra at ALLARM. All data of known quality have a use. Can you repeat after me? All data of known quality have a use. And that known quality is a really important piece when you're talking about data use. The other mantra that we have, which I won't make you repeat, is that the quality of data collected needs to meet the end use. So if you're looking to look at heavy metals and their contaminants in waterways, volunteer monitors aren't going to be the folks that you're going to use to collect that data. You don't have quality field test kits for those volunteers to use. You'll use certified labs. However, if you're looking for the impacts of acid rain on Pennsylvania waterways, pH and alkalinity, they're a great field test out there that volunteers can use. So these are things to keep in mind. And then the other thing is programs need to have clearly documented, and they need to use their quality assurance, quality control measures. And that's something throughout the United States volunteer monitoring program is a consistent theme. We always come up against that hurdle of quality control, and so everyone is very vigilant about making sure that they have clearly documented methods. Okay, so to dive right into our Watershed Technical Assistance Program, this is a little bit of the cycle we take with folks. So it starts with a community concern, and then the community members join and they form together and they're like, we have this concern. And then they're like, well, what can we do about it? What data exists about our waterway? Oh, there isn't a lot of data on our waterway, maybe we should collect it ourselves. That's when technical assistance comes into play. I was not responsible for that. The next thing that happens as the group is designing their study and they get that all figured out, then they need to be properly trained, using the right methodology, so on and so forth. They go through their trainings and then they get sent out to their streams to do their monitoring. The next stage we have with those volunteers is data collection and quality verification. I'll talk about that a little bit further later on. Then we help those groups with data interpretation. We don't do the interpretation, we actually do it ahead of time, but we create a workshop where the volunteers discover the data themselves and the story within their data, and then the communities use the data. But it's really intensive for the service provider. We can't have a really vast geographic reach with this because it requires a lot of mentorship. This here is a 10-step process. So for my brothers and sisters in the water quality monitoring field, if you haven't seen River Network's study design manual, this is a fabulous tool to help engage communities in answering all the questions they need to prior to starting their monitoring. And this is the place, and you'll notice in step 3, how will you use the data? Right up front, you have to answer that question. How are you going to use that data? Because that is the place where you assure that the quality of the data collected meets that intended use. So, but I'm not going to go through all those steps, but that's a key one. All right, so I'm going to provide a couple examples. So the Codorus Creek Watershed Association is highlighted in red. You'll see it's in south central Pennsylvania. And they had a couple of key issues in their watershed. They were formed in 1998, and they had this paper plant. Anyone ever monitor or seen the effects of a paper plant? Maybe in Canada you guys do it a little better than we do. I hope so. But it's really stinky. They use a lot of these hydrogen sulfides, tannins, so on and so forth. And you know, when you have an industry with a discharger, you know, they have a discharge permit. And because of this paper plant, the creek, the Codorus, and the town of York got the name Inky Stinky as their what people called them. That's not very nice. So the group, the Codorus Creek Watershed Association, had 2 main goals. They wanted to check out this paper plant because they were like, I don't think that they're in compliance with their discharge permit, right? And then they had other concerns about agricultural runoff in the watershed. And so they had 2 data use intended goals. One was for regulatory enforcement with the paper plant, and then community education around the agricultural runoff. So, you know, we helped them design a study, and then they went through the process of they got trained to use the different kits and things like that. They went through a quality assurance process where they send samples into us, and we test those samples using their methodology and more sophisticated methodology to verify that they're good to go. And this is what they found. So they clearly found that the paper plant was in violation of their discharge permit. And what they used, it's nice, it's jazzy. A lawsuit happened based on 2 parameters, temperature and water color. Isn't that amazing? Lawsuit. And look at the numbers here of what happened using those 2 volunteer collected data points. $2 million endowment for environmental projects in the town of York, $2.5 million in penalties, and then the plant was required to install $32 million worth of new equipment to improve their discharge. I mean, people, that's pretty jazzy, right? So we should way to go, Codorus Creek Watershed Association. So, they had this really big win, and I gotta tell you that this doesn't always happen. That's probably the 1% of water quality data and volunteer monitoring data gets used in this way for these lawsuits, but it's still really exciting. The group continued, and they took all of the data they collected and they generated a watershed report card in 2005, and then at that point they stopped monitoring and then started to transition into that restoration phase based on the hot spots that they identified in their data. So, go Codorus Creek Watershed Association. In Pennsylvania, there's a lot of common uses of data. Petitions, petitions, I'm not gonna get into that because some of that's a little nuancy. And a lot of it is community education, zoning, and all sorts of fun stuff. Okay, so I quickly went through watershed technical assistance, and I'm gonna have a very not so great transition into, now we're gonna talk about shale gas extraction. Woo! Okay, sorry again that this map, is very US centric and there's nothing shown with Canada. I apologize for that. So shale gas extraction, how many people here are familiar with fracking? That's what I thought. Good. It's an issue I'm glad to hear that people are informed about. So what this map shows is the light pink shows, so fracking occurs in shale geologic formations. So, because I'm not gonna get into that. So the light pink show where the shale formations exist. The bright pink illustrate where those formations have enough gas and it's deemed profitable to go after. That black circle over there is where Pennsylvania is. We're in one of the most profitable plays in the country. Okay, so this is my I need sympathy from Canada slide, and we'll see if it's not gonna work. It's this great, okay, we're missing it. So it's this great graphic that shows the rate of wells being drilled, and it gets really the state gets measles and stuff like that. And you all would have gone, oh, poor Pennsylvania, but that's not gonna happen, so, all right. So we have this great Clean Water Act, right? It's this nice federal act that we have in the United States. And, it's used to protect water quality and all sorts of things. But fracking is considered to be an unconventional natural resource extraction technique. And in 2005, our vice president at the time, Dick Cheney, put forth a Clean Energy Act amendment, which is commonly referred to as the Halliburton loophole. Which Halliburton was the company that Cheney was associated with. I'm gonna stop talking and get right into this. But what it did is that loophole exempted shale gas extraction from several federal laws, including Clean Water Act, Clean Air Act, and Safe Drinking Water Act. So now you guys, I feel sorry for us in Pennsylvania, okay? Okay, and so what happens is when you have the omission of your federal standards, it's then left up to the states how they're going to regulate this issue. So for example, our neighbors in Ithaca, New York, Jennifer Shirk, you can just smile all you want over there. New York had a moratorium on fracking until they figured out what they want to do with it. Pennsylvania, we started drilling that immediately once the loophole was in place. Blah, 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 blah. So what I'm saying here is the typical channels for us to use those federal and state standards were not in place for volunteer monitoring data to be used, which created that many more hurdles for us. But regardless of that, fracking was taking place. We were like, man, there's all sorts of impacts from this. And we wondered what role volunteers could have in addressing shale gas extraction and documenting some of these impacts. And so our science advisor and our technical Assistance Director, created our shale gas volunteer monitoring program, and this program has been adopted by 7 different states, which is kind of exciting. But it looks at 2 key things. One, it looks at whether or not flowback water, which is this really salty brine that is found with our shale, not true for all shale basins, so you have to check that out for yourself, but it is found with our shale basins. It's really salty. It's anywhere from 10 to 20 times saltier than ocean water, and it has heavy metals and all sorts of nasty things in it. It looks to see whether or not that flowback water is making its way into small streams, because if you have that salty, briny water coming into a small stream, it has a huge wipeout effect. And so we look at a couple different things that are on the right there, or the left, what is that, left? And we do use a combination of volunteer collected data and field techniques, as well as certified lab data for the barium and strontium, which are signature chemicals of flowback water. And I can explain this more for those of you that want to know those details. They also get a water level measurement. Elaine kind of introduced us to a little bit to that earlier. So that's that side, looking at flowback pollution. The other side of it is the physical impacts of shale gas extraction. And some people are like, the movement of sediment, that's not that jazzy to look at. Why would I care about it? Sediment is hurting our streams crazy bad. So this is we've had 42 violations reported by volunteers using our visual assessment protocol. And that looks at land disturbances, erosion, sedimentation, spills and discharges, gas migration. That is my foot flaring methane that has migrated through the geology and appeared 3 miles away from the nearest fracking site. So that's me flaring that, just in case you guys haven't seen methane migration in streams. That's what that looks like. Surefire way, hot to test it is to flare it. Did you guys get that? Surefire? No. Okay. Wake up. We're almost there, people. All right. And then also pipelines. My table was talking about pipelines earlier. Pipelines, oh my gosh, talk about earth disturbances. They're pretty bad. Anyway, so shale gas monitoring is a red flag protocol. Our volunteers are being trained so that when they spot something, they alert the regulatory agency to respond to it. So if you create a red flag warning protocol, it's really essential that you build a relationship with your regulatory agencies so that they respond to the volunteer calls. So we started trying to get the water quality division of our environmental protection agency in our state to use this protocol and respond to the calls. And we just, oh my gosh, I've never hit so many roadblocks with our own water quality people. And at the end of the day, they're like, we can't do anything with this. It's not in our jurisdiction. I was like, you could have told us that 8 months ago. But anyway, so they sent us over to the oil and gas division of our regulatory entity, and they handle all violations related to shale gas extraction in the state. So it took us 9 months to build that relationship, and it was the service providers with a couple of key volunteers coming to the table and talking to the agencies about how community members were being trained to use scientific data, they were establishing a baseline, and they weren't going to be crying wolf and so on and so forth. And the thing that sold them is in the peak of drilling, one day in July, our volunteer called in a violation at 9:30 in the morning, and the regional office that was fielding the calls had already received 149 violation reports. So there's a lot of noise, and the department technically has to investigate all issues. And so as a result, we established a memorandum of understanding that our volunteers' calls be prioritized. So that's my big, woo, look at those volunteers. We had to develop decision trees. So this is, if you guys have ever read Choose Your Own Adventure books, they're kind of like that. If you see this kind of violation, so for example, if you smell methane gas, if you smell the mercaptans, yes. And then, is it of imminent threat? You call the emergency personnel, and then you call the agencies. If no, then you go to other folks. And then we have other standards for pipelines and the flowback monitoring as well. Verifying the quality of data, we have our quality assurance, quality control measures actually written out into a quality assurance project plan that is being submitted to our federal agency, Environmental Protection Agency. Currently waiting approval on that. But we have rigorous QA/QC practices. Our volunteers go through a 6-hour training. They do the split sample analysis. They care and calibrate their equipment. They have to document how they care and calibrate. It's very rigorous. So that's a really important piece. So I have 2 minutes. Do I have 2 minutes? Okay, 2 minutes. All right, so I'm going to just tell you about some of our 42 violations that volunteers caught. This here is a frac fluid spill. The volunteer, I'm going to point at this one. The volunteer saw this murky water, and she had been monitoring her creek for 8 months. She saw this murky water in this beautiful trout cold water stream that was always clear. And she was like, doesn't seem too cool. Maybe I should walk upstream. And she did, and she kept walking upstream. And then she saw the frac fluid spill. And these are all different pictures of a frac fluid spill. So that was great. The responders got on the scene immediately and started cleaning that up. That was great. Another success story, this here is Ted Bear. He monitors in a county in Pennsylvania called God's Country. It's referred to that because it's very forested, and there's very little communities that live there, and fracking has been quite an eye-opener for that community. And he, at one time, was monitoring 13 sites on a weekly basis. And he was monitoring downstream of 4 different active well pads, and of the 42 violations, Ted's responsible for 14. So he was on the site, saw the violations, got the agency response really quickly. This here, for those of you interested in pipelines, so you have to do this horizontal directional drilling underneath of streams when you do stream crossings, and that's the preferred method in Pennsylvania, which typically is good, except we have this really old geology, and it's fractured and fissured, and they use this stabilizing clay called bentonite around the pipe underneath the stream. And so if that bentonite, and it's kind of like, you ever drop those sponges in water and they expand, you know what I mean? That's what happens with bentonite. When it comes into contact with water, it expands, and when it finds a weakness in the geology, it explodes into streams. And so these are pictures that our volunteers caught of a bentonite explosion near a well site. And then this here, you can't really tell. There was a weakness in the geology on the hill, and the bentonite came out of the side of the hill. That was really unintended. They got out there and cleaned that up really quickly. We did some work with our groups to do data analysis, and we did find a couple of situations where our volunteers found flowback pollution incidents. This was elevated conductivity in the summertime, so it can be associated with road salt in wintertime, and these should have been violated. And we talked to those volunteers, and one of the things they said is like, I don't want to cry wolf. And so that's something that we're addressing now with all of our groups, is helping them understand their data and knowing when they have a violation and making sure that they have that confidence to pick up the phone. They feel very comfortable with those visual indicators. That's the chemical indicators that we need to work with them on. For those of my water monitoring friends and colleagues, on a national level in the states, we are trying to get coordinated, and so there's a couple of resources that I can share with y'all afterwards. There's the National Water Quality Monitoring Council. There's a volunteer monitoring element of that, and we have listservs and all sorts of resources and things like that. And then there's some great resources out of University of Rhode Island, Wisconsin, of all these different best practices with volunteer monitoring. And so this website is awesome. If you're getting started and you're wondering where to go, this is a great place to start. So with that, I have gone over, so I guess I'll end it there. Thank you very much.